Today we are continuing the stream from yesterday, and today we are going to solve again LeetCode problems from using the NeetCode Blind 150. So yesterday we solved stack problems. These two, curve fit and largest rectangle in histogram. So for today we are going to try to solve these three output problems. Okay. So today I think from blind results, let's try to do the easy problems. Easy problem, binary search. Okay, so one second. So simply what we're going to do is what we'll basically do. Let's search. Let's search this. Let's go through the problem and try to understand, solve the problem. So binary search, given an array of integer nums which is sorted in ascending order, and the integer target writes a function to search target in a nums. If the target exists, then return its index, otherwise return -1. Okay, simply, and the algorithm should be of log n. So basically the binary search algorithm is of complexity of log n. Okay, so what let me first explain how we are going to solve this problem, then we will move on to writing the code for this problem. So let's put it here. Okay, now let's go through this problem and try to understand how to solve this problem. So for the binary search to work, the most important thing for the binary search algorithm to work is the array. Array needs to be in sorted order. Okay, basically array needs to be in sorted order. So the array provided here is already in the sorted order, in ascending sorted order. So what the question is asking simply is find 9 if it exists in this list of an arrays list or array, whatever. Okay, so if it exists, return its index. Okay, so this index is 0, 1, 2, 3, 4 and 5. Okay, so we know the indices 1, 2, 3, 4, 5. So basically what do we need to return for this 9? 4. Okay, if the target does not exist in the list, all we need to do is return -1. Okay, so let's try to understand how to solve this problem. Okay, so simply what we are going to do is we are going to create 3 variables. Okay, that will be simply low, high and mid. Okay, so what we are going to do is initially we are going to set low as index 0. Okay, and a high as whatever the size of the list is, -1. So the size of the list is 1, 2, 3, 4, 5, 6. So 6 minus 1, that will be 5. Okay, why 5? Because we need to know the last index. Okay, as a high, and for the low, first index, the first index 0, last index that will be 5. For mid, what we are going to do is low plus high. Okay, so basically mid is low plus high. So what we're going to do is we are going to solve this problem. So what we're going to do is check while our low is smaller than our high, smaller than or equal to. Okay, so what we're going to do is check if our low is smaller than high, as so 0 is smaller than 5. So what we're going to do is calculate the mean. Mean will be 0 plus 5 divide by 2. Okay, mid. Okay, so 0 plus 5 divided by 2, that will be 2.5. We can round up it to round up. We can we can upper round it to simply 3. Okay, so we have mid as 3. So what we will do is check. We're going to have an if statement. What we're going to check, if our mid, that is 0 1 2 3, that is 5. Check if our mid value, mid value, okay, if our mid value, okay, if it is greater than, sorry, if it is greater than our target, if our mid value, that is 5, is it greater than our target? No, it is not greater than our target. So what we need to do is, what simply we are going to do is, our low will be whatever the mid is plus 1. Again, we're gonna check if our mid value is smaller than, okay, if it is smaller than our target. So let's let's say, for some case, let's say our target is 3. So for currently, to understand, let's say our target is 3. So is 5 greater than our target? So as it is, so what we need to do is, whatever the our high value is, we need to mid minus 1. Sorry, okay, yeah, our high will be simply mid minus 1. Okay, so before any of these, we need to check if our mid value equal our target. Okay, if our mid value is equal to our target, what we are simply going to do is, whatever simply return mid. Okay, that's it, all we need to do is that's it. So for, let's say, for this problem, first what we do is check if our 5 is equal to 9. No, then if 5 is greater than 9, is 5 greater than 9? No. If 5 is smaller than our target, as it is smaller than target, sorry, if our 5 is greater than, is 5 greater than our target, so 5 is not greater than our target. So what we do is, low equal to mid plus 1. So this is not, sorry, what do you, let's once again, instead of doing like, if our value is smaller than our target, if our 5 is smaller than our target, what we do is, low will be mid, that is 3 plus 1, that will be 4. Okay, and if we again check, if our mid is greater than our target, no, 5 is not greater than 9, so we will not run anything. Then we move on to next iteration. So 4 plus 5, our low is 4, high is 5, 4 plus 5, that is 9. 9 divided by 2, that will be 4 point, simply 4.5, that will be 5. So 0 1 2 3 4 5. So 4 plus 5, that is 9. 9 divided by 2, that is 4.5. So 4.5, we round up. If we round up to 0 1 2 3 4, if we don't round up, let's say round, do not round up, because if you round up, what will happen? If round up to 0 1 2 3 4 5, so 5, so our mid value is 5. Is 5 that 5 as index? Then we check if 12 is greater than, is 12 greater than our target, as it is greater than our target. So we simply do is high equal to mid minus 1. That will be this one. So for high will be this, low will be 5. In next iteration, this will not run because our high is, low is 5, high is 4. Okay, so it will not run, it will loop away. Instead of rounding it up, we'll round it down. Okay, let's try to implement this logic. Okay, so let's start. Let's get 3 variables: int low 0, int high, that will be nums minus size minus 1. Sorry, it's okay, high. Then int mid, currently this will be 0 because initially initialize it to 0. Okay, and then another thing, int result, that will be minus 1 by default. Okay, because if we don't found the target in the nums, we need to return minus 1. Okay, so let's return result. Okay, so now what we're going to do is simply, while our low is smaller than equal to high. Okay, what we're going to do is find mid. Mid will be low plus high divided by 2. Okay, now what we're going to do is, we have low plus high divided by 2. Now let's check if our mid value, that is nums mid, equal target. If it is equal target, what it is, return mid. Okay, don't do anything. If our nums mid, if it is smaller than 5, if it is smaller than our target, what do it is, low equal to mid plus 1. Okay, so if again nums mid, if it is greater than our target, we simply do it high equal to high mid minus 1. Let's run this. So we are getting what we need. Let's submit this. Okay, so this works, everything works. So it is as simple as this. Okay, now let's move on to the next problem. That will be searching a 2D matrix. Now searching a 2D matrix. So searching a 2D matrix, given you are given an m cross n integer matrix with a flowing 2 properties. Each row is sorted in a non-descending order. Each row is sorted in an non-descending order, that is ascending order. Okay, the first integer of each row is greater than the last integer of previous row. So first integer of each row, the first integer of each row is greater than the last integer of previous row. So yeah, this is greater than this. Given an integer target, return the true if target is in the matrix, or false otherwise. You must write an solution in log m into n time complexity. Okay, so given this problem, we know the last index, the first index of this is greater than the last index of previous row. First index of this row is will be greater than the last index of previous row. So what we can do simply is, we know the target. So where can we start? Like, we have 3. So what we'll do is simply check the last element of this last element of the rows. If our target is less than the last element less than or equal to the last element of this any row, we know that that element exists in that row. Then we can simply implement the binary search. So first we need to do is find in which row the target exists, and once we know the which row the target exists, we can simply implement the binary search algorithm for that row, that specific row. So okay, so to check which row it exists, we know that the first index of next row is greater than the last index, okay, of previous row. So what we can do is, for target 3, what do we do? Check the last index. If it is greater than smaller than the last index, okay, if it is smaller than the last index or equal to the last index, we know this exists in this row. Then again we check in this row, then we check in this row, okay. So let's start writing the code. Okay, so simply let's do int low, that will be 0, int high, that will be simply that we still we don't know, then mid we don't know. Okay, so how can we do this? Let's first find which row it exists. So for each I is equal to 0, when I is less than matrix matrix dot j size, okay, I plus plus. Again, for each at int j equal to 0, while j is less than matrix matrix 0 dot size, okay, j plus plus. So this is for outside. So this is for the how many row it has. This is for how many column it has. Okay, so simply let's start with if each row end so where let's check the row end. Okay, so why are we doing from 0 to start? We know this size, we know this size, get the both size, keep on checking for this. Okay, let's get this int row size, that will be matrix dot size, and int row UL size, that will be TRX matrix 0 size, it is size. Okay. So for the size. Okay, so what you can do is simply check each row end element. So we'll loop through each row. Let's loop through each row size. Okay, we know the last column. Okay, to check if our row our target, if let's check if our matrix materials matrix row, that will be ith row, last element, that will be call size minus 1. Check if it is equal, here target, just return what do you need to return otherwise check if it is if matrix I equal size column size minus 1, if it is if this element is smaller than target. If our target is smaller than this, if our target is smaller than this, we know the row in which we have in the row which element exists. So all we need to do is simply which row it exists. Let's break before breaking, let's int row where target might be okay, that is by default. Let's set 0, then row where target might be will be I. Okay, so now we know in which row it exists. So all we need to do is once we get this, let's return by default this return false. Okay, also now we know in which row it exists. So while our low is smaller than or equal to high, all we need to do is simply check if let's find mid, that will be, so our high is simply, let's put it below, let's put this below, so our high is col size minus 1. Okay, so let's do low plus high divided by 2. Okay, so low plus high divided by 2. Let's check if AX matrix, that is row, we know that row, let's copy this, paste it here so that we don't have a spelling error. So let's do, then mid, if it equal target, then we return true. Okay, then copy this line, paste it again. Let's check if our mid element, if it is smaller than, if our mid element is smaller than our target. So what we do is simply but low will be need plus 1. Then if it is smaller than, our this is our mid is greater than our target, we need to do high. We need to do this high. So this high will be mid minus 1. Okay. That's it. So first we do is try to find out in which row that might exist. That might exist. If like if let's say we need to find 16. Oh, is 16 is smaller than equal to 7? No. It is, if it is smaller than, so if it is not smaller than this, we can be sure that 16 does not exist in this row. Then we check, is 16 is equal to 20? No. Then again, is 16 is smaller than 20 as, so we can be sure 16, if 16 exists, it should exist in this row. Okay, so let's run this code. Okay, so we get the answer simply. So our code runs. So let's give this code to the ChatGPT and try to find the time complexity of this problem. Okay, so let's see complexity. So simply row, that's a linear search, that will be where this is O of m. In the worst case, you will search all the row. Okay, O of m. In a binary search, for that it is log n. So it is m plus log n. Let's see if is this. So this is this it better or better than O of log m into n. Except no, this is no, this is better or equal to equal than this in most cases. So no, this is better in most cases. Let's simplify. Let's log n. So you are comparing system. M plus log n. So n equals faster than log n. Okay, so what we do is simply, okay, so what we can do is, again, we have computed this as this. So what we do is, we're gonna, let's copy this, let's paste it here, let's move this out, let's do this, let's implement again same binary search algorithm for these. Okay, for these. So let's implement again. Let's do one second. Let's add a O of m plus log n plus log n. Okay, so now let's remove this. Simply, instead of doing this, doing it like this, what we will do is it will be row size. So all we will do is let's think it like this. Let's remove all of these. Let's just see the last index as a what do you call last index as a list. Okay, last index as a list, and let's just go through those index. Just only go through those index. Try to find the element. Okay. So what it is. So let's move this such below. Now we need to find in which row it exists. So for that, say apply. While, so we know we know the last index of the last index, that will be row, last index of last column, each column. So all we need to do is check if low is smaller than or equal to, while our low is smaller than or equal to high. All we have to do is check, let's find mean. It will be low plus high. Divide by, okay. Now let's see if what in matrix. So we know mid, that's mid, and the last index, that will be column size, okay, -1. Going with we are just checking the last column, okay. Let's see if this is equal. Starting what it is, return true if, let's stop this. Paste it. Let's paste this. Let's check if our last index of each row, if it is greater than, if it is greater than our target. So if it is smaller than, our target, simply what it is, low will be mid plus 1, okay. Let's see if our last element is of each row, last element is greater than our target. So what it is, high, okay, mid -1. By doing this, if it's equal to this, it's smaller than this, will do this, so let's say for target 3, so we go to 20. Is 20 greater than, is 20 greater than, it's 20 greater than 3. So no, 20 is smaller than, so what we will use, simply will reduce is 3 is 20 smaller than, sorry, is 20 is smaller than target, no, is 20 greater than target, yes, it is 20 is greater than target. So if 20 is greater than our target, that is 3 is 20 greater than 3, yes. So what it is, our high will come here. Let's see if it is equal to 5. So this will never happen. All we will do is keep on doing this. So how can we do this? Let's say for this one, if it's not equal to, we'll move on. Okay. At the end, we'll have this. So we'll move on to here. We'll check again. Here is our target. is our target equal to this. So our target is this is target 3 is smaller than this, but it is also smaller than this. So what will these return? What will these return? So they come here. This will not run. This will not run. This will not run. So at the end, what will happen? Get a meet. This is this room. Again, get this plus this divided by 2. So let's say 1 sorry, that is low is equal to 0 plus 0 plus 0 divided by 2, that will be 0. So we know that it's in 0th. So at last it's over. This mid will be STT, C out. Let's run this. So that is 0th for this one. 13. 13 is not here, so return false. If we do submit, I think this will give some error because we have only simple conditions. Find the mid. If it is equal to target, we'll simply return true. If it is not, we will go finding the last index. We'll go here, so it will keep. Let's say our target is 16. So it is smaller than this. Yes, it is smaller than this. So it is smaller than this. We'll move on to here. So 16 is smaller than this. Then we'll check if 16 is smaller than this. Yes. Then we go over here. It is more greater than this. Yes, it is here. Then again we'll move up to here. So we keep on moving from here to here, here to here, here to here, here. 16. So what it is, our low is here, high is here, mid here. So it is smaller than this. So what it is, our low high will be mid minus 1. That will be this. So this. So high is this. The low is this. So again 0. So 0 plus 0. That is divided by 0. That is 0. So again it's 7 greater than is 7 smaller than target as it is. So all it is low is equal to this. Low will be this, but low will be mid plus 1. Okay, that is clear. So again we'll move on ahead. Low will be this, high will be this. Low will be this, our high will be this. Low will be this, our high will be this, and 4. Low is this, and the high on the other. Okay. Okay, some. Okay. So what it is simply low. Let's say it is less, our target is 34. So we'll get mid. It will low will be this plus this. So again low. So again this plus this, it is smaller than this. So our high will go here. So there is a problem, I think. Let's try. Let's submit it. This will give an error. Neither this will give an error because our to this also. If you do low, some problem will be solved. Some will fail again. So that will fail again. If you do high, there will be problem. Still, there will be an error. If you do mid, still be an error. So what can we do? How can we do this? Let's say if low and high, instead of doing it like this, target will say if instead of mid, finding mid, checking if it is smaller than, let's say if this is our low, this is our high. So let's say if our target is greater than our low, yes, our target is greater than our low, will increase the target here. Check if our high is, if our target is smaller than our high. If both, if this was let's say 16, so is 16 is smaller than 60, yes, so we have decrease our high and increase our high. Let's check if our low is greater than our high, yes it is, then I will increase to here. So when this is equal to this, we'll have this. Let's say our 34 is, this is smaller than 34, yes, we will move on to here. Is this, then is 17 greater than this, so it will move on here. So they both are equal. Then again, is 70 greater than this, we'll move on here. Is this equal to this, is this greater than this, yes, this will move on here. So it will keep on both. This will move on here, this will move on here, and again this will move on here, this will move on here. Both will low and high, both will be here. Let's say 5, let's say 5 is our target, let's say 3 is our target. So is this is smaller than this, yes, so what it is, and there is high. If the target is smaller than low, we return low, then we plus 1, then low plus 1. It is smaller than this. If it's smaller than if it's smaller than this, so what can we do? What can we do if we want m log n? We get the mid, the smaller than mid. If it is smaller than mid, but greater than low, greater than this, smaller than mid.
तो एक ही अपडेट आया सर.
One second.
हाँ.
एक second.
हाँ.
One. So let's continue. Continue to the continue. Let's continue with the problem. Okay. So what can we do? We find the mid. If it is smaller than mid, so we know that it should be lower than high. This it is smaller than mid. Instead of doing it mid plus one, mid minus one, let's do this. So at last, what will happen? If it is smaller than mid, so if the target is smaller than this, okay, if our mid, if our mid which is smaller than this, mid is smaller than our target. Yes. If our mid is smaller than our target, this is, and if our mid this is greater than our target. So it is for high. If our mid, so how can we do this? Let's say if our, let's say for 16, for the 16 is our if it is smaller than our target, so at is it is smaller than our target. Okay, so 16, 20. So 16 and 20. So 16 and 20, but it is greater than this and smaller than this. Means if our mid is, if our 20 is target, 16 is more than this, yes. And check again, if it is greater than low, if it is greater than low, it is smaller than target, this, and greater than low, we do this. It is smaller than our target and smaller than our high. Greater than our let's if our it is smaller, this is smaller than this but greater than this, so we can be sure it's not in this one. So but it will be anywhere in between. If our this is our target is target is that is 16 is greater than our height. It is not greater than our height. If it is not equal to, it should be smaller than our height. How can we do this? How can we do this? If our mid if our mid is smaller, so it is smaller than mid and greater than this, it is simply put it here. Then mid again we check if it is smaller than our height. If it is greater than our height but it's smaller than our target, it is greater than our mid but smaller than our high. What it is, you see, if our mid is smaller than our target, and mid L minus 1 and it is greater than our low. Fix low size minus 1. If it is smaller than our target, if it is this, then what it will simply it can be in this row, it can be in middle row, it can be in anywhere. This one, this row, so we simply do increase bit by +1. Increase the low +1 and our high will be mid. Again, let's see if it is greater than this but smaller than this. Our matrix, whatever the element, our target is greater than our mid. Matrix high, which is size -1. If it is smaller than our high, if it is greater than our mid, smaller than our if it is greater than this, smaller than our high, is smaller than our high, we can be sure that it is smaller than our high. So it can be this too. So what it is simply can be in this row, it can be in this row, it can be in this row. So it is smaller than this. Basically what it is, we can be sure simply our high will be same. High will be same. All we do is low is equal to it is greater than this mid +1. We have mid +1. This is greater than this but smaller than this. Our high will be same. Mid +1 for this one. If it is smaller than this, so our mid will be same. Our high will be mid. Low are greater than this. So it is greater than our target. If it is smaller than our target. So simply what we are checking, if our mid value is smaller than our target and greater than our low, so we can be sure our high should be mid, low should be +1. So if it is smaller than our this target, this smaller than or equal to this, but greater than our high. Greater than high, so we can do low plus this, and our high will be same. High will be high. High will be high. This low will be mid +1. So high is the same. This will increase, and this will increase, and high will reduce to this. And this is greater than this. Target is greater than low. Target is greater than or equal to this. So let's for 16, and this will be mid. So so our mid is this. So our target is smaller than this, okay, but greater than this. So low will be this, our high will be this way. Okay. And then it will come here. So it is greater than this. No. It is smaller than this. No. So this will not run. So let's say for 13, 34. Let's for 34. So if our target is smaller than our, then we can find this 20. Is our target greater than 20? Yes. Is it is smaller than our high element? Is smaller than or equal to high element? Yes. So what is it? We do this. We do this to this, and then this. And when the for this middle is our mid value smaller than our target. Yes, it is so smaller than our target. It is our current value is greater than our target. That is solution. Then we check if it is smaller than our high. Okay, that will be mid +1 value is, while our high is not equal to low. We get this one. Means our high and low are both same. Sure. For a high one. This one. Let's copy this. Let's put in the charging day. Let's do it. These and these are solving the passport. So how can you use it? So if it is target is greater than or equal to this, it's smaller than our, this one will be mid and break. Okay, we are made breaking. Use the target is smaller than our mid. The target is instead of last element, we are taking first element. Okay. target is greater than this, smaller than our target minus 1, okay, we return this. Then let's do this. Let's remove this. Oh, that was. Let's remove this. Okay. So what we do is simply check instead of last element as we are checking here. So we check first element. Let's check if our target is greater than or equal to this row of first element. Then we have matrix that is that will be or need 0, okay, and target is smaller than or equal to its matrix need that is set whole size minus 1. If it's true, we have found the row, okay. Simply what it is, row by default the way that might be will be minus 1. What we do is copy this, paste it here, will be minus 1, so it will be need, okay. And we will break, okay. If it is not, else if it is not, what it is, if the target is greater than our matrix need 0, if it is greater than, or if it is target is greater than our mid value, it is whatever mid value plus first element, what it is simply our low will be mid, okay. Else simply if it is not smaller than this, if it is not greater than this, not greater than this, so you can see also all indicators I is equal to mid minus 1. So is it correct? Okay, so is it correct? It is mid minus 1, mid plus 1, but we are checking the first element. So if you are checking the first element, it will be anywhere. So for that we already have this, okay. Let's also see. Plus 1. For that we already have this. You check. Check if our minus 1, then we will return false. Yes, we have to return. We just run this. If it is smaller than target, and if target is smaller than equal to mid, if ATRX matrix, ATRX matrix, X matrix. So simply what we need to do is, while this is true, we find the mid. After find the mid, check if this element, our target is greater than this element and is smaller than the mid, what do you call it, mid last element. If it is, we know that we have found this. Okay. Otherwise, if it is not, if it is mid is, otherwise what is simply check if target is greater than, so 10 is greater than 16. So we know that. So what we do is simply this will be mid plus 1. Mid plus 1. So it is not in this row. We can be sure it is not in this row. So but it is greater than this. It is not in this row, and it is greater than this. So it will be in next row. So simply low plus 1. If it is smaller than this, but it is not in this row, it is smaller than this, we can be sure it is 1 minus 1. Okay, sure. Log. So for this binary source entropy problem, we need to remember one thing. So after checking the row wise, if it is in that row, we break and the mid. If it is not that row, we get plus 1, get minus 1. So that is as it is. So let us move on to the next problem. That will be Coco eating banana. Coco eating banana. So we go through the explanation. See what is the explanation.
Hey everyone, welcome back, and let's write some more NeetCode today. So today let's solve search a 2D matrix. And I really like this problem because it's not one of those problems that you need a fancy trick for. You can actually solve this problem just by using logic. So we are tasked with creating an efficient algorithm for searching for a single value in an m by n matrix. The matrix has two properties. In every single row, the integers are sorted from left to right, and
So there is even more optimal solution. So we still watch it. 1 second. This one again. It is not this. It is log m plus log n.
the first integer of each row, for example, this 10, is always going to be greater than the
This. When you treat the whole matrix as a 1D array, so check if it is greater than this, they will find the mean. This both length and breadth, whatever this will come, check it is
last integer of the previous row, so greater than this one. So in other words, we know that each row is sorted, and then the next row is going to be greater than that. So technically, each value in total throughout the entire matrix is going to be in sorted order. So that's pretty good. In this example, we were given a target 3, so if we search for the target, we will find it right here. So then we can return true that it does exist. If it does not exist, then we simply return false. So how can we solve this problem? The key word here is create an efficient algorithm. What would be the brute force? Of course, we could do an algorithm O of m by n, basically by searching every single value in the input array, right? That's a pretty easy algorithm to do on a two-dimensional matrix, but can we do better? Of course we can, because they gave us a couple properties that this matrix has some sorting already applied to it. assume that we just had a single row. Like, forget that we had a matrix. If we just had a single row like this one, and we know it's in sorted order, do you know an algorithm that can search for a target value in a sorted array? I know of one called binary search, right? And how efficient is binary search? Well, let's say the size of this
So it's 0. So this is this for both of it and mid. Let's do it. So mid will be always similar. Mid will be the same. Mid will always be low. Okay. That will be always 0. Int high. There could be a 2. There is no provision that there is no thing that is a square matrix. It cannot be even a square matrix. So we need to do is I1, that will be just for row. What is the size? Okay, that is -1. Okay, and int ch high, that will be a matrix 0 dot size -1, while row is smaller than equal to it's I1 and row is two rows equals row 1 and row 2. Okay, int row and row 1 is smaller than I1 for the rows, and this is smaller, row 2 is smaller than or equal to just high okay. All this should be and or odd. So if it is 0 0, this is 1 2 3 4, 1 2 3 3 by 3 4. 0 plus 0, 0 plus 0 divided by 2, 3. 3, that will be 2. So 2 for 4, we'll have 2. So 3 divided by 2, that will be 1. 1 divided by 2, 1 and 2, 11. So we got 11. And again, for this one and this one, it is 11. It's it. If it is greater than or small. If it is greater than, all we will do is it's greater than this plus both mid and if it is both low 1 and low 2 by 1, it will come somewhere. This is 1 2 1 2, so that will be 2 3. That's will come here again. It will come here somewhere. It will come somewhere here. We set up low this plus this plus here. So low will be this or high will be this. Plus this way. Check this middle. So this middle, that will be, let's say this is 1 3. So 1 plus 3, that is 1 plus 3, 4, that is 2. So 2. Then 3 plus 4, that is 7. 7 divided by 2, that is simply 3. So 3. So 0 1 2 3. So 2 comma 3. So that is 0 1 2 comma 3. So that will come here. It's greater than this. This we can let's put
this array is n, we could do a binary search in log n time, right? But of course, we know that we actually have m different rows, right? So let's say we ran a binary search on every single row until we found the input target value, right? What would the time complexity be? Well, log n multiplied by m is going to give us a solution like that. So that's using the first property, knowing that each row's integers are sorted. And this is a pretty good solution, but can we do even better than this? I'll give you a hint. We're definitely going to have to use this second property that they told us. Each row itself is actually in sorted order, as in we know that the values in this row are going to be smaller than all of the values in this row, and all of the values in this row are going to be smaller than all of the values in this row. So can we use that property to, instead of searching through every one of these m rows, maybe we can actually do a binary search just to figure out which one of these rows to search in the first place? Because, for example, if we're looking for a target value 3, let's take a look at this row. This row could have any values between 10, which is the lower bound, and between 20. So obviously the target value 3 is not going to fall within that range between 10 and 20, right? So then the question is, okay, if the target value is definitely not in this row, we can cross this row out. But then which direction are we going to go? Are we going to look at the row above it, or are we going to look at the row below it? Of course we would want to look at the one above, right? Because above, the top row is going to have smaller values than the bottom row, right? So when we cross this row out, we can also say that, let's cross this row out too, because of course this row is going to have greater values. That's how the binary search is going to work, to even figure out which one of these m rows we're going to need to search, right? So we can reduce, instead of m, we can do a log m by running binary search. After we've ran that log m search, then we know, okay, this is the row that we have to do our second binary search on. So after we're done with that, we're going to do another binary search. So let's plus here log n, right? Log n for binary searching the row itself. So that's a better time complexity than we had previously, right? Log m plus log n. That's pretty dang good. So once we get to this row, we're going to say, okay, 3 is what we're looking for. Does that fall in the range between 1 and between 7? Of course it does. So either our target value exists in this row, or it doesn't exist at all. So let's run binary search here. So of course we're going to have 2 pointers, left pointer and right pointer. Then we're going to check the middle value. In this case, I think the middle value is going to end up being this one, because 0 plus 3 is going to become index 1. But let's just say it became this one, just to kind of show you what it's going to look like. Let's say our middle value is here. We're going to check, okay, 5 is that 3? Nope, 3 is less than 5. So what we can do in our binary search is cross out these values, cross out our pointers. Now our right pointer is going to be over here. And let's say we ran binary search again. We compute the mid to be over here. We check, is this 3? Nope, 3 is greater than this. So we cross this out and we shift our left pointer over here. Left and right are both here. Middle is going to be here as well. We're going to see, okay, either this has to be 3 or nothing, or 3 just doesn't exist. Of course, this is 3. So we found it. We can return true. And that's the entire solution. So it's just a double binary search, and we can implement that pretty easily once you kind of know how to do binary search. And if you don't, I'm going to show you how to do it right now. So now let's get into the code.
good. The solution the way he explained, we just solved the similar way for log m plus log n. Okay? But the problem is that us to solve log m into n. Okay? So how can we solve it in log m? Before doing that, let's copy this one. Copy this one. Let's go over here. Let's copy this. Let's paste this. So this is the problem that you how I was trying to do it. Okay. This greater than this. So instead of doing this, we forward this. Read the last element. Small button. This. Let's see, this greater than button. This 0. Please. Break. And what's this? Okay. Target JSON right B minus 1. Let's return once minus 1. This one's so this also works. The my code the previously I wrote was correct. All the things that I wrote was correct. Just I was not able to figure out how to know in which row it exists. So this one I was not able to just figure out. Okay, so that was the issue there. Okay, so this is fine. One second. So we already solved the way the NeetCode had solved. So let's ask him to solve it in this. So can we solve it like this? Okay. This one becomes this one. So total elements is n plus n. So 4 is 4 index mid. Mid with n. So what it is, I will be n plus n. So is this, I will say plus n minus 1. Plus n minus 1. So we found the mid. So we need to find the row and column using the mid. So we need to look at it. So I'm not understand this how this work explanation. Okay, so think of the matrix as a one long array. Okay, so this is a nice array. The row are sorted. So each row starts after the previous row ends. Okay, so like this. So that's sorted one, only. So if we do this, and then log n plus n. So this that's a sorted 1D array. But we still have 2D indices. We do not physically convert it to them. We just pretend it's 1D. So mapping 1D indexes to 2D position. So let's say n number of columns. If you pick indexes in a fake array formula. So, for example, this matrix n is 3. So indices, let's say 5. Then 5 divided by 5 divided by 3, that will be 1. So for row 1 column 5 and percent 3, that will be 2. So matrix 1 comma 2 will be 11. So 1 comma 2, that is 11. How binary search works here? We search log 0 and high, that is plus n minus 1. So find the middle index, find the middle index. So middle index also convert to row and column and compare value. Find the middle index, convert row plus 1. So step by step. This means low is high of this one, so middle will be 4. This is 1, this is 1, this value is 9. Found it again. If not found, why this works, the matrix is globally sorted, so there is no break in an order. So binary search logic is still found left side, which is smaller than mid, which is greater than right side. So that is true. So when this does not work, matrices is like problem sorted. If it is problem sorted, it will not work, but globally sorted. Flatten the array would be this one not sorted, and this search fails here. So simply what we are doing is, so this is this. If we have to solve it in, so if we have to solve it this into this, we do is copy this, paste it here. Now all we do is we have row and column. Find the number of row, find the number of column. Then we do int row, that is equal 0, int height, that will be m minus 1. Okay, so now that is while smaller than or equal to, it's high. What we do is find mid that will be 0. So it is equal to low plus high divided by 2. Okay, now we need to find exact row and column in. We are trying to solve it as a 1D matrix, but we need row and column both. So to get a row, there is a formula. The row that will be mid divided by 2, and for int column that will be mid divided by 7%2. So that is, and not ampersand 2, that is mid ampersand n. So ampersand n. Ampersand n. Whatever the size of the second matrix is, the size of the second column. So this size. So I think for this problem we need to remember these things. We need to remember this row and column. Then it's simple as it is. It's like if PRX matrix row and CR equal target, then turn to if matrix row column, if it is greater than target, it is greater than target, what it is will be mid plus 1 matrix row and so it is smaller than target, what we need to do is if I is equal to minus 1. So is this how it is smaller than target, if it is smaller than, it is smaller than our target. If our row and column is smaller than our target, so it is in this side. So if it is smaller than our target, it is so just return t and return as false. So if our current, let's say it, if this is smaller than our target, it is smaller than our target. So this is smaller than our target. That is, so this is smaller than our target. We can take the loop, digit. This after with 16, it is smaller than after it has so we will plus 1. So this one. So, and with row size to serial size, column size. Okay. So now it's running of log of m plus n, okay, which is fine. Is to right. So log of n term. Okay. Let's see. Okay. Let me write it. Right. So that's it for today. We'll continue tomorrow again with more of the binary system problem. Okay.